There we go, and we're starting up again with part two of this video. If you remember where I left off a few seconds ago, well, it was only a few seconds in my world. I don't know, maybe you paused and stopped watching for a while. We're just running through this list of values over here. And like I said, I'm going to look at this one, and then for each after that, I'm going to check to see if it matches. And as soon as it no longer matches, which in this case for the first one would stop immediately, I'll break my for loop. So, how do I do that? What I really need to do is keep track of what my current run is. So I'm going to need another variable. Keep track of how long my current run is. And for the I, it's my run starts at 1. It's the same as my longest run at 0. Or not, there are no others. Never mind. I could have done 0 or 1 there. Whatever. My current run is 1. And now I need to check for the rest of these things. So now I'm going to do int j. I use I again, so I'll do j equals, and I want to start at the next one, so I'll do I plus 1. So on the first one, I'm setting I as 0, and then I'm looking at j, which is the first element. And as long as j is less than values dot length. So this time I can go all the way to the end of the values because I'm not worried about going. My big concern was if I'm looking at this one and then J and I'm trying to look at this, again, I'm getting an out of bounds index. That doesn't exist. But if I'm stopping looking at this one to look at this one, then I should be fine. And obviously, the run starting here is 1 because there are no more else after that. I hope it all made sense. Anyway, it made sense in my mind. All right, so what are we going to do? If values I, oops, that was ugly. And I erased much. Oh, there we go. If it equals, double equals to check, value j, then my current run is getting longer. Current run plus plus. Let's increment it by 1. If it's not getting longer, then I may as well stop. And I can stop that loop by doing a little break, and that'll kick me out of this for loop if those values didn't match. Let's try to keep this on the page. There we go. Now, I've gone through each additional one until it no longer matched. So now I need to check if my current run is greater than longest run. And then my current run must be the new longest run. So I will set longest run to what my current run is. And I want to now set my index to I, because where my current run started was at I. I'll close my bracket. And then I think I am done. I can close my for loop because I'm going through each one. I'm setting a current run at 1. I'm checking each value after that until I no longer have any matching. And if that current run is longer than the longest run, I'll reset my longest run. And if it's longer, I'll set the index to the one that I was at. And I think I'm done. And then I can return my index. Again, this is not the solution that Canonical provided. If you want to look at their solution, you can actually look. Here you go. I've got it pulled up. You can go on to collegeboard.org and you can actually pull up their response. Theirs is a little bit different. Wow, can I write on this? I think I can. Maybe not. Oh, I can. That's cool. They that was fun. Sorry. They did it a little bit differently. They just went through each element and then basically we're adding up if it was the current length, and then if it wasn't, you'd start over again. It's maybe a little cleaner, except that this max start, the start of the current one, that one got a little bit confusing to me with the arithmetic. And it's not honestly the way I thought through the problem when I first saw the problem. So I gave you my solution. I'm pretty sure I would get a full score because it does accomplish what it needs to accomplish. Um, but it isn't exactly the way that they came up with it. So again, this emphasizes there are lots of different ways to do it. Um, if I were honestly evaluating my method versus theirs, I think mine's easier. I felt like mine was easier to understand, but theirs is definitely more efficient. Uh, but in a powerful enough computer, that's probably not going to make a significant difference. But it's something that's at least worth considering and keeping in the back of your mind as you progress and become professional computer science scientists.